Hey everybody, we are here talking about exponent rules, or maybe exponents rule? Exclamation point? Question mark? I don't know. You decide. So in this video, we're going to go through some of the most important rules for how we can work with and manipulate exponents. So let's start off with this. So let's say I have 2 times 2 times 2 times 2 times 2 times 2, let's count, times 2. That should be 7 2's, and we're multiplying all those 2's together. Wouldn't it be nice if there were a shorthand that we could use in terms of notation for how to write 2 times 2 times 2 times 2, etc. 7 times? Well, this is that notation, exponent notation. You've seen it before. 2 to the power of 7 is how we would say that, or 2 to the 7th power. And the 2 there is going to be our base, and then the 7 is going to be what we call our exponent or our power. Let me just put nice little circles around here. Okay, perfect. So 2 is the base and 7 is the exponent or power. Now, the important thing to remember about exponents is that they may seem fancy, but really exponents are just repeated multiplication. Say it with me. Exponents are just repeated multiplication. Let that sink in. Okay, moving on. Let me erase this. All right, so let's talk about the first thing here. So let's say we have something like this, 2 to the negative 1 power. What does it mean to multiply by 2 by itself negative 1 times? Well, in order to illustrate that, let's write some other exponents and see if we can reveal a pattern. So I've got 2 to the 0, 2 to the first power, and 2 to the second power. So 2 to the second power, or 2 squared, we know that that's equal to 4. 2 to the first power is going to be equal to 2. And then anything that's not 0 to the 0th power is going to be equal to 1. So now let's look at what's the pattern here. If we go from 4 to 2, I'm just dividing by 2 to get from 4 to 2. And similarly, I'm just dividing by 2 to get from 2 to 1. So if we continued that pattern and we divided 1 by 2, then what would we get? Well, we'd get 1/2. And that's what 2 to the negative 1 power is equal to. Now we could take that a step further. Indeed, we could take it as many steps further as we want, but right now let's take it to 2 to the negative 2 power. And so we're just going to divide 1/2 by 2, and that's going to give us 1/4. 1/2 divided up into 2 parts. Each of those parts is going to be 1/4 in size. And so up here on the upper right, let me rewrite that. Sorry, not rewrite it. Let me write the next step in this. So 2 to the negative 3 power, that's going to be equal to 1/8, because that's just 1/4 divided by 2. And you may notice a little pattern here. If I have 2 to the negative 3rd power, that's the same thing as writing 1 over 2 to the 3rd power. So 2 to the negative 3rd power is the same thing as 1 over 2 to the 3rd power. So let me erase and make some space here and write out the rule. So any number with a negative exponent, so 2 to the negative 1 or 2 to the negative 2, etc., any number with a negative exponent is equal to the reciprocal. Now, the reciprocal is just 1 over that number, is equal to the reciprocal of that number with a positive exponent. So a number with a negative exponent is equal to the reciprocal of that number with a positive exponent. So 2 to the negative 3rd power is the same thing as 1 over 2 to the 3rd power. And this works the same way with exponents. A to the negative b is the same thing as 1 over a to the b. Similarly, 1 over a to the b is the same as, I just erased that too quick. 1 over a to the b is the same as a to the negative b power. Okay, let's continue here. So next rule. Let's say we have 3 squared times 3 cubed, or 3 to the 2nd power times 3 to the 3rd power. Now, if we were to write this out longhand, just remembering that that exponents are repeated multiplication, then I'm just going to write 3 times 3. That's going to be the same thing as 3 squared. And then I'm going to write 3 times 3 times 3, which is the same as 3 cubed. Now, if I count all those 3's, then I'm going to see that there are 5 3's, and so that's the same as 3 to the 5th power. Now, you may see a pattern here. The exponents are to the 2nd and 3rd power. What I can really do here is just add those exponents together. 3 to the 2nd power times 3 to the 3rd power is the same as 3 to the 2 plus 3 power, which is the same as 3 to the 5th power. So, when multiplying two numbers, let's see, how should I write this? When multiplying numbers that have the same base, with the same base, I can talk faster than I can write, believe it or not. With the same base, we just add the exponents. We add the exponents. And the key here is that you have to have the same base. So up in the top left corner here, we have 3 to the 2nd power times 3 to the 3rd power. 3 is our base for both of those numbers, and so we can add the exponents together. If we have different bases, it doesn't work. You can't add them together. Now, it's the same with variables. We have a to the b power times a to the c power. That's going to be a to the b plus c power. Okay, let me erase this. We'll move on to our next rule. Let's say that we have 4 to the 5th power, and we're dividing that by 4 to the 2nd power. Well, I can write this out longhand. That's going to be 4 times 4 times 4 times 4 times 4 at the top. That's just 4 to the 5th. And then at the bottom, we're going to have 4 times 4, which is 4 squared. Now, you may remember that when we're multiplying terms and we have the same the same term on the top and the bottom, then we can cancel them out. So I can cancel out 2 4's on the top with the 2 4's on the bottom, and that leaves me with just 3 4's on the top, which is 4 times 4 times 4. I've run out of space here, so I'll come down on the next line. That's just 4 to the 3rd power, or 4 cubed. Now, similarly with our last rule, you may notice that there's a little bit of a shortcut here. 4 to the 5th power over 4 to the 2nd power is the same thing as 4 to the 5 subtract 2 power, or 4 to the 3rd power. 4 to the 3rd power. And so the rule here, if I can write it out, I'll try to write it out a little bit faster. The rule here is that when we are dividing numbers, really need to get faster at writing this. When dividing two numbers with the same base, just like before, we need to have the same base. So we have the base of 4 for both of these numbers that we're dividing. When dividing two numbers with the same base, we subtract the exponents. And you're going to subtract the exponent. You're going to start with the exponent in the numerator, and you're going to subtract from that the exponent in the denominator. So in our case, it was 5 subtract 2, because we had 5 as the exponent in the numerator and 2 is the exponent in the denominator. Now it works the same way with variables. A to the b power divided by a to the c power is going to be the same thing as a to the b subtract c power. So dividing numbers with exponents is like you subtract the exponents. That's our little shortcut. Okay, moving on. Let's see. Oh yeah, my daughter's drawing. She wanted to draw this thing, and then she says, you can't hear her, but she says, what is this thing? And I don't know what it is. She didn't know what it was either. So maybe you can inform us what this thing is. Question mark, question mark, question mark. Who knows? Okay. All right, moving on. Erase, erase, erase. All right. So the next thing that we want to talk about is when we have a situation like 3 squared, and we're raising that whole thing to a power. What do we do with those exponents? We have 3 to the second power, and then all of that is to the 4th power. Now, remembering that exponents are just repeated multiplication, we can write this out. So 3 squared is 3 times 3, and we have 4 of those. So 3 times 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 3. How many 3's am I multiplying together here? I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 3's. So that's going to be 3 to the 8th power. So let me rewrite this. 3 to the second power, and all of that to the 4th power. You may see a pattern here. I just multiply those exponents together. That's going to be 3 to the 2 times 4 power, or 3 to the 8th power. So, when raising a number with an exponent to another exponent, or raising it to another power, we multiply the exponents. We multiply them. So that's 2 times 4 makes 3 to the 8th power. It works the same way with variables. A to the b power raised to the c power is just going to be a to the b times c power. All right, moving on. I've got a few problems here that I'm going to write out, and I want you to work out these problems on your own. So I'm going to write them out, and then I'm going to pause I'm not going to pause. I'm going to keep going. What I want you to do is for you to pause the video and see if you can figure these out, and then I will go through and solve them myself, and we can see if we got the same answers. So the first one here I wrote out is 3 to the second power times 3 to the third power times 2 to the negative 4th power, and then all of that squared. And then the next one, the second one, is negative 3 to the negative 2 power. And then the third one is a to the third power. Okay, I'm about to start writing it out. So pause right here and see if you can figure these out for yourself. So for this first one here, I'm going to start by multiplying those two exponents that have a base of 3. I'm sorry, adding together the exponents for the numbers that have a base of 3. And then I'm going to multiply those by 2 to the negative 4th power. And then I'm going to raise all of that to the second power. So I can't combine 3 to the 5th or 2 to the negative 4 because they have a different base. But what I can do is I can take that exponent that is outside of the parentheses and distribute it over the terms that are inside. And so I end up with 3 to the 10th times 2 to the negative 8th. And then we'll just remember that 2 to the negative 8th, that we can move that to the denominator and change the sign of the exponent. Okay, next one. Negative 3 to the negative 2nd power. Remember, when we're raising something to a negative power, then we can move it to the denominator and change the sign of the exponent. And then negative 3 squared is just negative 3 times negative 3. And when we have a negative multiplied by a negative, that makes it positive. And so we end up with 1/9. Check mark. Okay, and then finally, these variables here. A to the third power over a to the first power. When we're dividing numbers with exponents, and those numbers have the same base, then we can subtract the exponents, and that gives us a to the 3 subtract 1 power, which gives us a squared. Check mark. Okay. Let me erase this. And here's a picture of a goat This has nothing to do with math, but I thought I'd put something in here at the end. I went to a sheep and goat fair once upon a time when I was living in Qatar in the Middle East, and it was a place. It was like a dog show, but for goats. And I don't know if you can see in this video those things sticking out to the side. Those are the goat's ears. I just thought this goat was like Shrek. It was like a Shrek goat. It was the funniest looking goat I've literally ever seen, and there's some funny looking goats out there. So I'm glad you stayed for this picture of a goat, completely unrelated to math, and that's the end. Exponent rules.